So they could ask you an exam question where they give you a list of data and you need to identify any outliers. Now they will always tell you in the question what method to use to find the outliers, but the specification mentions two in particular. One of them is to do with the quartiles. So an outlier is defined as any data point that is less than Q1, where Q1 is the lower quartile, minus 1.5 times the interquartile range, or an outlier is any data point that is bigger than Q3, which is the upper quartile, plus 1.5 times the interquartile range. We'll go for an example question in a moment that uses this method. And then the other one is to do with the mean and the standard deviation. So an outlier is defined as any data point that is less than the mean minus 3 times the standard deviation, or an outlier is defined as any point that is bigger than the mean plus 3 times the standard deviation. Now, if you have an outlier, there are two possibilities for what it could be, okay? So firstly, it could be an actual value in the data. So for example, let's say that we have a list of people's heights in centimeters, and we have these values here, and then using one of the methods that we talked about before, let's say that we identified this value here, 201 centimeters, as an outlier. Now, in feet, 201 centimeters is 6'7", and this could be a genuine value in the data. Someone actually could be 6'7". It's just a very tall person. But in this data here, this is an outlier in the data, okay, although it is a genuine value. Now, another possibility is that an outlier could be an error, and I think the textbook does a good example on this. So let's say you have a list of ages of people, which is this list here, and using one of the methods from before, you identify this value at the end, 165, as an outlier. Now, this is obviously an error because you cannot have a person with an age of 165. And sometimes what we will do is do something called cleaning the data. And what we will do is if we're calculating stuff like the mean or standard deviation with this data, we would actually ignore this one if we were pretty certain it was an error and just use these data values here, so this doesn't affect any of the calculations that we do. Okay, so here's an example question where we're told a list of data is shown below, which is this here, and a value smaller than Q1 minus 1.5 times the interquartile range, or bigger than Q3 plus 1.5 times the interquartile range is defined as an outlier. So this is the first method that we talked about at the start of the video. And using this information, we need to find any outliers in the data. So to do this question, firstly, we need to find the quartiles and the interquartile range. Now, we talked about how to do this for a list of data in the quartiles and interpolation video, so go back to that if you need a reminder of how to do it. Firstly, we need to find the number of data points in this data. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10. So let's start by finding the lower quartile. So to find the lower quartile, we need to find n over 4, so this is 10 over 4, so this is 2.5. Remember, when you have a list of data like this here, we're going to round this to the next whole number, which is 3. So we're going to find the third value in the data, which we can see here is 18. So therefore the lower quartile is equal to 18. So now we need to find the upper quartile, so this is 3n over 4, so this is 3 over 4 times n, which is 10, which is equal to 7.5. We're going to round this to the next whole number, which is 8, so we need to find the 8th value, which we can see is 23. So the upper quartile is equal to 23. So therefore the interquartile range is the upper quartile minus the lower quartile, so it's going to be 23 minus 18, which is equal to 5. So this is the interquartile range, okay? So now we need to find the outliers. So let's start with this one here. So it's Q1, which is the lower quartile, so this is 18 minus 1.5 times the interquartile range, which is 5. And if you put this into your calculator, this is equal to 10.5. So any values that are smaller than this are an outlier, and we can see we have one value that is smaller than this, which is 9. 9 is smaller than 10.5, so therefore 9 is an outlier. So now let's look at this here. So Q3, which is the upper quartile, which is 23 plus 1.5 times the interquartile range, which is 5, which if you put this into your calculator, this is equal to 30.5. So any values that are bigger than this are an outlier. We can see the biggest value is 26, which is not bigger than this, so therefore we don't have any outliers on this side of the data. So therefore we only have one outlier. 9 is an outlier. Okay, so now let's move on to box plots, or they're sometimes called box and whisker plots as well. And you're probably already aware of these. It looks something like this here. So what a box plot says is this here is the minimum value, and you can see that on this axis here the minimum value is equal to 2, and then this here is the maximum value, and you can see that on this axis here this is 19. And then we have this box here where this line here represents the median, and you can see in this case on this axis this is equal to 12, and then we have this here which represents the lower quartile, which you can see is equal to 7, and then we have this here which represents the upper quartile, which you can see in this case is equal to 15. So this is the information that a box plot tells you. Now, some box plots will have an X on the graph like this here. So what does this mean? Okay, so let's say that we have a list of data like we did before, and we identified one of the data points as an outlier. This X here is the outlier. So what this means is this value here is the maximum value in the data that is not an outlier, because obviously this value here is the maximum value in the data at 17, but this value here at 13, this is the maximum value in the data that is not this outlier here. Okay, so here's a past exam question on box plots. So pause the video, have a go at the question, and I'll go through the answer in about 5 seconds. Okay, so for this question we're told each member of a group of 27 people was timed when completing a puzzle, and the time taken X minutes for each member of the group was recorded, and these times are summarised in the following box and whisker plot here. And for part A we need to find the range of the times. Okay, so the range is the maximum value in the data minus the minimum value. So the maximum value is this outlier here, which is 68, minus the minimum value, which is this here, which is 7, and therefore this is 61. So the range is 61. I feel like some students might say that this is the maximum value, as they might feel like that you shouldn't include the outliers here. We talked about in this video about cleaning the data, and sometimes when we're calculating stuff like the range, we might not include the outliers, and we do that sometimes. And if the question said that, find the range of the times not including the outliers, then we would use this as the maximum instead. However, there is no point in this question in which it says to ignore the outliers, so this here is the maximum value. Okay, and then for part B we need to find the interquartile range of the times. So the interquartile range is the upper quartile minus the lower quartile. So the upper quartile is this value here, which is 25, minus the lower quartile, which is this value here, which is 14, and 25 minus 14 is 11. So this is the interquartile range.